Alrighty, everybody. Good evening. This is Chuck Schultz again with Patriot Builders PFC and Michigan Sawmill Sales. Can't forget that one. Um, we're here tonight. We're going to do the second video for the anatomy of a Michigan pole barn home. We're going to touch on the exterior wall section. It's really not rocket science, but it's what our style is and what we do to achieve everything in the exterior wall framing. And then it will tie into, when we get to the insulation video, when I do that one, it will tie into why we frame the exterior wall sections the way we do. So I'm going to touch base on some drawings that I have received drawn by other draftsmen or architects on some post frames that we have to work with on bidding and everything like that, and kind of not so much pick on them. It's more of, there's many different ways to do a pole barn or post frame, and then as we're turning it into a home, as a post frame home, a Michigan pole barn home, getting the wall section done in a way that is I guess to the residential code. The traditional pole barn framing, like people know, I'm going to touch on the header systems. We're not sandwiching on each side of a post the headers, so like you got two members that are acting as a double header, whether it's two 2x12s, two LVLs, whatever it is. We actually put the headers together, mechanically fastened together, and then attach them to the columns. So I'm going to flip the camera around. I'm going to show you a print and another detail from another print that might have kind of followed what we do, but there's still some things on there that we don't do. And it's going to explain, I hope this is going to explain some clarity in what we do. So let's get at it. All right, everybody. So right here, I'm going to touch on this print right here. So there's a detail of a wall section. Let's go to this one first. So not that this draftsperson did, or design, or architect did anything wrong. There's, like I said, there's many different ways to skin a cat in these, but I'm going to touch on the header system right here first. So this print had two LVLs fastened to either side of the post. And so even though this print required bearing for two LVLs, they had them split apart to sandwich the post column. And sometimes, well, all the time in residential framing, it poses another problem for draft stopping, for fireproofing the house. So in the code book wants draft stopping vertically, everywhere in a wall cavity, and I believe it's something like it's 10 linear feet side to side. So in our case, between columns, every 10 feet we got to have a draft stop going lateral. I'll get into that in a minute. So up here, if you notice, they were on the right track with creating the thermal bridge, breaking the thermal bridge right here. That is about a 2-inch space between the wall girts on this plan, which are shown right here. Some people call them purlins, but that's for the roof deck when they do that up there. But these are technically called wall girts. And then in between the columns, they got this 2x4 studded wall in between to hold the drywall. And the way they have this here, it pockets up inside this header cavity up to the plate height where the truss is set. And then they have it capped off with a 2x6 in here. To me, as a framer, that would be more of an annoyance detail right there, and I wouldn't want to frame it that way. It would just cost more time and energy, and it would cost more money per the build. And then there's a difference, they're attaching a deck to the, there's like a second level to it, and the way they got that detail. I mean, I can punch on that on another particular video, but I just want to focus on the wall cavity, the wall framing. So this, again, we typically don't want to do that. We want to basically sandwich and mechanically fasten these headers and then let them into the post column, and and we'll get into this next one is off of a different print. They started getting closer on the header detail to what we do. So basically right here, it shows the two LVLs fastened together and then fastened to the column, actually let into the column. So there's a notch into the post column, and the header sets in that notch, and then is basically held strong by 1.5 inches past the column to line up with the wall girts, as you see here, all the way down. Again, this one, they're trying to attach a second level here, or a mezzanine level, but it's all finished. That is not the best way, in my opinion, to do that. Now, one thing I want to pick on this drawing is they got wall girts on the interior. You see here, 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 down on the interior, and then they got the drywall finish right here. And then insulation in between. One thing I don't like about this is that this print doesn't show any type of framing for rigidity inside the wall cavity. Yes, it doesn't have a thermal bridge to speak of, but I mean, that's a good thing. But that's just not really how we like to do things. So, you know, this is a couple of examples from other designers that it's just more of a nuisance of frame, and it's just not an efficient frame to do. So got our sensitive information blocked off by those plywood clips. So let's move on to what we do with our Michigan pole barn homes. So here is a detail of the wall section. Let me take this over here. I'm going to move this a little bit out of the way. We'll get to that picture in a second. That will show us how we actually connect our headers to the columns, and then how the truss set goes on, and a little bit more clarity, and how our interior wall frame goes in, and it accomplishes all the fire stopping on that drawing there. So, but now this is a cutaway basically of our exterior wall system shown from the inside without any of the siding or insulation in the way to confuse things. But this is showing how we frame in between a wall section between columns. So we're going to start on down here at the footing. So this is a spread footing. So this view over here is as if we took a saw and cut this wall section here and was standing and looking in that direction right here. So we're going to pick on this. This is the interior side of the frame of the exterior wall. We've got our post columns sitting in sturdy wall brackets or an equivalent, which is basically that big boy right there. Those things are super strong, like I covered in the other video of the foundations, and they are mechanically fastened to the top of the footing. And then this right here shows the insulation and the slab of the flat work, and then our wall sets on that. We got a single bottom plate. Anytime that bottom plate touches concrete, it must be pressure treated. And then we have our vertical studs placed every 16 inches on center up here. So that's what those vertical lines are showing, 1.5 inch wide stud. These horizontal lines are on the outside of the posts here and here. That is the wall girts. That is the substructure that holds the siding and the home wrap and everything else like that. Up here, this horizontal member here is the header, the double LVL, shown from the inside of the house again. Those two dots right there are the bolts that hold the header on. That is sitting in a 2-inch notch on the column. And then these are indicating these verticals right here, 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 and here, and so on. Those are the trusses setting on there. So that is indicating this section of truss right there, setting here, here, all the way down. Now you notice I have just a single top plate on there. That's because this wall, this interior frame in between the columns, are not actually holding any weight whatsoever. So this is just like a non-load bearing interior partition. So like this is kind of just like a finished basement wall or something like that. It's just holding drywall, electrical fixtures, stuff like that. Now this diagonal drawn in here, this diagonal member right here is a 2x4 wind brace. It goes from the top of a column to the bottom of the next. And that is for racking and rigidity. Kind of what the exterior wall sheathing does in a standard platform frame or stick frame building. So that eliminates the need for sheet goods on the exterior wall. And that is placed on the back side of the header and wall girts. But on the outside, in that 2-inch cavity, this is key, that 2-inch cavity between the 2x4 stud framing and the outside wall girts, that's where this wind bracing is attached. So, and that provides our thermal break in this wall. And we'll touch about what the thermal break and how it performs in the insulation video. So we're looking at this cutaway on the side. I know it's really hard to see a lot of this detail, but this outside line is indicating the outside profile of the siding. Then that's the inside profile of the siding at the tip, and also where the home wrap goes. Then we've got our wall girts attached to the column, the outside of the 6x6. As you see here, the header is a double LVL spec'd out on this drawing, mechanically fastened together with a 2-inch notch in the column, so it's letting it in 2 inches. Now this double LVL together, they equal 3.5. So if we come in 2 inches into the post, we're cantilevering, I guess you would say. So it's outside strong by 1.5 inches, bringing it flush to the outside of the wall girts. So the siding plane goes right up on that. Okay, and then this is the top plate over here, which is the studded wall, the 2x4 studded wall all the way down to the floor. And then all those squiggly lines are the insulation, and then this other double line is the drywall line. So let's put this into a little clarity. We're going to look at this detail for the header fastening to the columns, and then we'll show a little bit of an overlay of how the truss sets on, which is another bonus feature of these, which I'll get into in just another second. So again, just like the other drawing, this is the outside surface of the exterior wall, showing where the header, which is called out as a double 11.25 LVL, typical on this build. So as that header's going on, it's spreading over where the 6x6 column comes up. That's our wall girt, 2x4, and so on all the way down. That's a break line, so I didn't draw the whole thing. So zooming in on the side profile, if I cut this and looked on the side, this is what we would see. This is the double LVL, mechanically fastened together on itself. And then right here, we notch the post column. This is 2 inches in and up. So this 3.5-inch wide laminated header now is sitting on 2 inches of the post. Then we through bolt it, and then we countersink the back so that the washer and the nut can countersink from the surface of the 6x6, because this is the inside wall plane. This is the exterior wall plane of the frame right here, this outside line. And then after, when we tighten all this up, we'll just take a cut-off tool and cut the nubs of the bolts off so that the drywall can just float right on past this. Okay. Now we get down, these are the wall girts, and again, transferred over here, that's what they look like on the outside, that's what it looks like on a side profile. So we have another wall girt here, and then so on, no matter how tall the wall is. Then we come up, remember, this header is cantilevering over by 1.5 inches, so we technically want full bearing on this header. So these blocks I'm going to talk about right here. So this is a side profile, so this is indicating a block on the flat, nailed to the post, cut tightly between the header and this first wall girt right here. And then again between wall girt and wall girt, and so on until we reach the footing. So that this header right here has got a full 3.5-inch bearing capacity all the way down to the footing. So we're not just sitting on this post column by 2 inches, and I know there's through bolts to it, so it shouldn't matter, but some plan review inspectors say it does. So this gives comfort for them when they're doing review of plans or whatever, that even though it's bolted, it's still got a positive contact to the full width of the beam sitting down to the footing. And this is what it looks like on the outside. So we have this block here is on the flat nailed to the post, and this is what it looks like here. So it's a tight fit between the bottom of the header to the first wall girt, from the first wall girt to the second wall girt. We block that in solid again, and so on. So two things that this little block right here, and again shown on the side view, what that little block does is that provides full bearing capacity of that header down to the footing. And since we don't put our post columns more than 10 foot apart, in our code, every 10 linear foot of wall, there must be a vertical draft stopping. That block provides it. So without that block, this would not pass code for just the fire stopping or the draft stopping. So let's move on a little further. Let's imagine there is a truss sitting on top of this header right now. So we're going to flip this little makeshift drawing over, and hopefully you can see transparently through this drawing. Give me a hot second. Let me get this aligned up. So imagine now we've got a truss or a rafter sitting on this header. It's not sitting on the post. It's not sitting on this wall. So this is showing the interior studded wall coming up to that point. And then now this truss is sitting on the header that has got, this is shown like a little Simpson strong tie hurricane clip or strap. For all intensive purposes, we don't have hurricanes in Michigan. But if you notice, this hurricane strap is nailed and fastened to the header and then fastened to the bottom cord of the truss. So let's go back over here. So one bonus feature of doing that is that it makes every single truss sitting on that header have a positive mechanical connection all the way down to the footing. In a platform framed house, normally this would just be a studded wall with a double top plate, and this little Simpson strap would just be connected to the top double top plate. Well, if you really had to depend on that strap, it would just break the top plate off, and you're really not getting any strength out of the weakest link is the structure, not the Simpson strong tie. So ceremonially, it's just showing the inspector that it is properly fastened to the top of the wall, however that would be. So now, in a post frame, the way we do that, on all these trusses sitting on the wall, they're connected to this header. Now we're looking on the inside of the frame of the wall. But each one of these trusses is going to have a Simpson hurricane strap connecting to the header member, which is going from column to column, notched, sitting on a good bearing point, and through bolted at each location. That connection is transferred down on each column to a sturdy wall bracket or equivalent, as shown here, which is then anchored to the foundation. So that detail gives us a positive connection for the roofing members all the way down to the footing. So we've got great hold down for wind loads and stuff like that. So, and these things are just awesome. We just won't even do a pole barn without them anymore. We don't put posts in the ground anymore. It's all done with that, whether it's a bolt-on application like what's shown here or a wet set. Okay, going back to over here. So I just discussed the fire blocking that has to happen in our Michigan code every 10 linear feet vertical draft stopping. Now when we go and frame the interior pars, we got a clean section. We can frame the wall on the ground and just stand a baby right up there and that letting this header in by 2 inches gives us a 3.5-inch pocket to the back side of the column, perfect enough for a 2x4 studded wall to go up there. And we only need a single top plate because this wall is doing nothing but holding drywall. It is non-load bearing whatsoever. All the load is on this header right here. So hopefully this gives oh, one more thing. This also creates a solid mass for the full width of this wall, which is 7 inches. Solid mass meaning no drafting going up into the attic, because if in these in these cavities right here, if there happens to be a little fire brewing right here, and if there was a way for air to draft up, once that fire gets into that attic, it's over for that structure. Or if there happens to be a draft over in this area, pulling air here, where there's a fire here, it's just going to suck that fire laterally. So that is another good reason why we do these blocks between wall girts all the way down to the footing. So we got lateral draft stopping every 10 feet going that way, and this provides our draft stopping going up into the attic. Hope this helps everybody with understanding a little bit of our wall frame on these and what sets everything apart from what we do. I know there's multiple ways to build these structures, and sorry about the unsteady holding of the camera here, but that's what a Michigan pole barn exterior wall section looks like. And again, this right here is what the header connection, how the trusses sit on there, and our interior wall frame in between columns look like. Thanks again for watching, everybody. And until the next video, we'll be talking later. Thank you.